This is Ms. Color. Welcome to part 2 of the solutions admit slip. Okay, let's talk about solubility curves. CK12 does a great section on solubility curves, so please go there and check that out. Okay, so using the solubility curve, determine the amount of each solute that can dissolve in 100 grams of water at the given temperature. 100 grams of water is normal for this. This is what you're going to see. And look at it right here. It says grams of solute per 100 grams of water. So the solvent, and then the grams refers to the solute. Okay. All right, and then what do we have at the bottom? We have temperature going across the bottom. Okay. So right now we're just going to find out how many grams of KNO3 at 70 degrees. 70 degrees Celsius, okay? How much solute will dissolve at that temperature with this compound, okay? So what we do is we find our line for KNO3, okay? And our line for KNO3 is right here, if you see it. I wish I had a color version, I apologize. So now I know which line I'm looking at. Now I go to my temperature and I go to 70 degrees, okay? Which is right there. So I'm going to follow 70 degrees up until I hit the KNO3 line. Okay? And it hits about right here. And if you go over like this, you see that it is 135 grams. Okay. Let's see the next one, NH4Cl at 90 degrees. Identify your line. Here's my NH4Cl, so it's this line right here. And then it's at 90 degrees, and here's 90 degrees. So I'm going to follow it up until they meet. That's just barely over the line, so I'm going to put about 71 grams. That's, oops, it's very close, 71, 72 grams, okay? All right, NaCl at 100 degrees. NaCl right here is your line, okay? And here's 100 degrees, follow it up. And that's actually, if you follow it over, is on the 40 gram line. Let's look at NaNO3, which is this line right here. And it's at 35 degrees. So 35 degrees is right here. And I'm going to follow it all the way up till I meet that line and go over and find out how many grams. And that's 100 grams. NH3 at 20 degrees. So NH3, here's your NH3 line. Okay, NH3, there's the line. At 20 degrees. So NH3, here's my line. NH3 at 20 degrees. So I'm going to follow it up. And it hits kind of between 50 and 60, so I'm going to say about 55. Now your eyes may be younger, so you might be able to get a little bit closer with that. But I think it's about 55 from my point of view. KClO3. Hey, KClO3 right here. That means it's this line right here. Okay, so at 65 degrees, which is right here. So KClO3, I'm going to go up until I meet it, and it actually follows over to the 20 gram line. So let's see, NH4Cl. NH4Cl is right here again. Okay. And it's at 10 degrees. 10 degrees is right here, so I'm going to follow it up, and I get what? NH4 at why did I say 10 degrees? Sorry. NH4Cl is 65 degrees. Okay. NH4 looks like it's about 58. NaNO3, okay, up here at 10. So here's my 10. That's the one I was looking at. And then I'm going to find right there, and it looks to be about 78 grams. Okay? And that is how you read a solubility curve. Okay? Now the bottom part, the next part of this, of the solubility curve, is different because this one is actually asking for if it's saturated or unsaturated. Okay, let's answer this question first. A glass of cold soda with lots of carbon dioxide, that's what makes the bubbles in the pressure in your soda cans, is left to stand for 5 minutes at room temperature. How does temperature affect the solubility of carbon dioxide? And the G is for gas. Okay, and it's going to lose solubility, making it less fizzy. Technical term, less fizzy, because that's what produces the bubbles, are the CO2. And if you're losing solubility on that, then it's obviously not going to be as fizzy, and it's going to start to separate out, if that makes sense. So temperature has a lot to do with it. Okay, so here's another solubility diagram, and what we're going to do is we're going to find out, is it saturated, unsaturated, or supersaturated? So if it's saturated, it's on the line. If it's unsaturated, it's below the line. And if it's supersaturated, you guessed it, is above the line. Okay? So the first one is actually pretty tricky. So it's 120 grams, okay? And that's still going up this axis over here, okay? And my temperature's still going across the bottom, and I'm looking at NaNO3. Okay? And NaNO3 is way up here, okay? Excuse me. So we want it at 50 degrees, okay? But we want 120 grams, which this graph did not give us. So you got to imagine that it continues on up like that, okay? So that's why this one's tricky, and I apologize for that. So here's your 50 degrees, and if you follow it all the way up, it's probably... It's tricky. It's hard to tell if it's super saturated or saturated. Okay, that one is very hard to tell. And I won't give you one of those anymore. That's my fault. And then, of course, we can mark another one of these off that I messed up on. There is no NH4Cl on this one, so we're not going to do this one. Okay. All right, 40 grams of NaCl at 90 degrees, okay? So we have to find our 40 over here, and then we find our 90 over here and see where they meet, okay? And they meet exactly on that NaCl line. I hope you can see that. They meet right there, and it's directly on the line. So that means that it is perfectly saturated. Perfect sweet tea is what I think about. 10 grams of KNO3. Okay, so where's KNO3 on here? And we see it right here. Okay, so 10 grams is down here, this line, and 30 degrees. So here's 30 degrees, and here's 10 grams. And what do you notice? This is our line right here that we're looking at. And this is where 10 and 30 meet. So it's under the line, okay? It's under the line, so it's unsaturated. Okay, so now let's look at KNO3 again. Same line. 80 grams this time, which is way up here, and then 50 degrees. So 50 degrees, I'm going to follow it up to where it says 80. Okay, that's where the 80 line meets. and there's the KNO3 line, okay? So technically that's under the line, so that's also unsaturated. So if I had given you one that was 40 degrees, it would have been here, it would have been super saturated because it would have been above the line. So above the line is super saturated, exactly on the line is saturated, under the line is unsaturated, okay? I hope that helps, and I'll come back with another video on how to calculate molarity.